Good morning, viewers. I'm K. Pradeep Kumar. I'm working as an assistant professor in the Department of Agricultural Engineering, Nanda Engineering College. Today, I'm going to take the fluid kinematics. Before we enter into the topic, we should know what is meant by fluid mechanics. The fluid mechanics is the branch of science that deals with the behavior of fluid at rest and also in motion. This branch of science that deals with the static, dynamic and kinematic. Study the fluid at rest means that is called the statics. If we study the fluid at motion and if we are not considering the pressure force means that is called the fluid kinematics. If we consider the pressure force also means that is called the fluid dynamics. Now we will see the fluid kinematics. That is the study of fluid in motion where the pressure force is not considered is called fluid kinematics. See this example. Here the water is flowing through this pipeline. Here I am only consider the flow or the motion of fluid. Here I didn't consider the pressure force means that is called the fluid kinematics. The different types of fluid flow is there. Steady and unsteady fluid flow, uniform and non-uniform flow, laminar and turbulent flow, compressible and incompressible flow, rotational and irrotational flow, one-dimensional, two-dimensional and three-dimensional flow. I will explain one by one. First, steady and unsteady flow. What is meant by steady flow? Steady flow means we consider the fluid characteristic like velocity, pressure, density do not vary with respect to the time. Means that flow is called the steady flow. The fluid flow does not vary with respect to the time. Means that flow is called the steady flow. Here the water is flowing through this pipeline. I am measure the pressure and velocity at 10 am. Here the pressure value is equal to 10 bar, velocity value is equal to 5 meter per second. After 1 hour, I will again check the pressure and velocity. Here the pressure is equal to 10 bar, velocity equal to 5 meter per second. See this two time duration, the pressure at 10 am equal to 10 bar, 11 am also 10 bar. There is no pressure difference. So this flow is called the steady flow. The fluid properties does not vary with respect to time means that is called the steady flow. Second one, unsteady flow. Unsteady flow means the fluid properties like density, pressure and velocity vary with respect to the time means that flow is called the unsteady flow. See this example. Here the water is flowing. I measure the pressure at 10 am. The pressure is equal to 10 bar. After 1 hour, again I measured the pressure value. Pressure value is equal to 13 bar. Here at 10 am, the pressure value 10 bar. 11 am, the pressure value is equal to 13 bar. The pressure variation is there. And also the velocity is decreased. At 10 a.m. 5 meter per second, 11 a.m. 3 meter per second. So the velocity and the pressure, that is the fluid properties, vary with respect to time, means that is called the unsteady flow. Next, uniform flow and non-uniform flow. The uniform flow means the velocity does not vary with respect to the distance, means that flow is called the uniform flow. See here, for water is flowing in this pipeline, I measure the velocity in 1 meter. Velocity is equal to 5 meter per second. After 1 meter distance, again I measure the velocity. Here the velocity value is equal to 5 meter per second. So at the section 1 5 meter per second, and the section 2 also the 5 meter per second. The velocity does not vary with respect to the distance, means that flow is called the uniform flow. Here see the example, the water is flowing before the stone, the water is flowing uniformly. Here the velocity value same, and also this point also the velocity value is same. So that flow is called uniform flow. Uniform flow means the velocity does not vary with respect to the distance. Non-uniform flow, in which the velocity vary with respect to the distance, means that is called the non-uniform flow. See here, at 1 meter distance, consider this taper pipeline. At 1 meter, the velocity is equal to 20 meter per second. And in 2 meter, the velocity value is 5 meter per second. The velocity value decreased, the velocity value changed. If the velocity value changed with respect to the distance, this distance means that is called the non-uniform flow. See this diagram also. Here the water is flowing. In this region, the diameter is decreased. The velocity value vary. So this is a non-uniform flow. In this region, the velocity, the pipeline diameter is same. Here the uniform flow is occurs. Okay. So the velocity does not vary with respect to the distance, means that is called uniform flow. If the velocity vary is from distance to the distance, means that is called the uniform flow. Next one, the laminar and turbulent flow. In that laminar flow, in which fluid particle move along well-defined path. The fluid particles move along well-defined path, means that flow is called the laminar flow. And also the Reynolds number less than 2000, means that flow is called the laminar flow. Turbulent flow. Reynolds number greater than 4000, means that flow is called the turbulent flow. The fluid moves in very irregular path or zigzag way, means that is called the turbulent flow. See this example, the velocity is vary, that fluid particles does not flow in a same line. Okay, irregular path, that follow the irregular path or zigzag way, that flow is called the turbulent flow. And also the velocity at a point fluctuates. Next one, compressible and incompressible flow. Compressible flow means the density is not equal to constant, means that flow is called the compressible flow, in which the density of fluid changes from point to point. That is, the density is non-constant for the fluid, means that flow is called the compressible flow. For incompressible flow, the density is equal to constant. The density value does not vary, means that is called incompressible flow, in which the density of fluid do not changes from point to point. That is, density value is equal to constant, means that flow is called incompressible flow. Next one, rotational and irrotational flow. In rotational flow, the fluid particles, while flowing along streamline and also rotate about their own axis, means that flow is called then rotational flow. Irrotational flow means, in this example also, the fluid flow in along the streamline and do not rotate their own axis, means that flow is called the irrotational flow. One-dimensional flow, two-dimensional flow, and three-dimensional flow. For describing one-dimensional flow, we need only one coordinate. Okay, here the x coordinate, the velocity denoted u. In y coordinate, the velocity is denoted b. In z coordinate, the velocity is denoted w. For describing the velocity in x coordinate, that means the one-dimensional flow, the velocity u is equal to the function of x coordinate only. The remaining two coordinate will be equal to the 0. For velocity at y coordinate, that's equal to 0, and also the w equal to 0. For two-dimensional flow, we need two coordinates to describe the velocity. Here, velocity u equal to function of x comma y. This two coordinate is required to describe the velocity. For the v equal to function of xy and w is equal to 0. For three-dimensional, we need three coordinates to describe the velocity. U is equal to function of x coordinate, comma y coordinate, z coordinate. V is the function of x, y, z. W is equal to x, y, z. Okay. Now you see the definition. For one-dimensional flow, it is the types of flow in which the flow parameter such as pressure, velocity and elevation are the function of time and one space coordinates only. For the two-dimensional flow, it is the type of flow in which the flow parameters are the function of time and two coordinate space, that means x and y coordinate space. For three-dimensional flow, it is the type of flow in which the flow parameter vary in all three directions, the streamline or space curves. Okay. Thank you, viewers.